So in discrete mathematics, the problems most of the time that we are discussing is about counting. Actually, there could be, I can divide it into two categories when we are describing discrete mathematics, are discrete structures problems. One is about counting discrete structures or finding patterns, and we may count or we may not count, but finding certain kind of patterns. Most of the time, we are counting some discrete structures in it. The other kind of problem is about logical inferences, logical arguments, and proofs. So these are main two categories in discrete structures or discrete mathematics. And from here, we develop like graph theory and we develop probability. So let's see what kind of problems we are going to discuss in discrete mathematics. For example, if we talk about counting structures, these could be counting numbers, counting number of sets, counting graphs, counting some patterns. So I give you one example. For example, we need to count possible passwords. When we enter password, we select some passwords. So there are certain constraints set by the system. So over here, we can see like, for example, on a computer system, we have to set a password. Password should be 6 to 8 characters long. And each character could be, for example, just uppercase letter or a digit. So we have like 26 uppercase letters and 10 digits. So there are 36 possible characters. And there are some constraints. Often when we select passwords, so there are some constraints. So we put constraint, each password must contain at least one digit. So how many possible passwords are there? So how many users we can accommodate on the system? We can make this problem more complicated so that we have more security. So for example, we put more constraints like password is still 6 to 8 characters long, but each password must contain at least one digit, one uppercase letter, and one lowercase letter. And sometimes we put extra condition like there should be some special character. So there are going to be like billions and billions of passwords. So number of passwords should be very high so that it's not easily cracked. And then another problem is about the graphs. We represent some structures, some relationship between entities with the help of graphs. So over here, nodes are some entities and the links or edges are some relation between them. These could be, for example, a road network, a relationship network, an electric circuit, or it could be anything where we can define a relationship between the entities. So how many possible structures, possible graphs or substructures, subgraphs could be possible in a very big graph? Over here, we have shown some simple graph, but graphs could become really big. So let's see, for example, over here we can see like this is a graph with 4 nodes. So we ask like how many triangles are there? So triangles are like mutual relationship between 3 entities, between 3 nodes. Here we can see like this is like one uh, triangle, second triangle, third triangle, and then outside there is another fourth triangle. So there are 4 triangles. But as the graph getting bigger, counting triangles become a challenging problem. We cannot just see how many triangles are there. And actual graphs are so big, like there are thousands or millions or even billions of nodes. To find how many triangles are there, so we have to be very clever. We have to find certain kind of algorithms to find how many triangles are there. And then there could be like different kind of question, not just triangles. For example, we want to find cycle. Triangle is a short cycle with 3 nodes. There could be big cycles. And then later on, we can study in discrete mathematics or graph theory. So about Hamiltonian cycles, trees and spanning trees, complete graph, bipartite graph. If you don't understand these problems right now, it's fine. We will discuss about these problems. What are these? For example, in Facebook, so if there is a network of 100 sites, but you know, like Facebook is billions of nodes size. So how many friendship networks could be there? Or in Google, so there are like trillions of pages. So uh, how does it work? So how many pages have higher rank than, for example, your page on Google? So these are all counting problems. Wherever there is word how many, it means we are going to count. This is a typical problem of maze solving. So we can define a graph out of it and find a solution for this thing. Actually, it is going to be a tree structure. And what other problems we solve in discrete mathematics? Mostly these are about logical arguments. From logical arguments, we can make inferences, we can make proofs. So proof, whenever we make a statement, we need to prove it so that everybody agree, everybody convinces with our argument. Here's this small little logical puzzle. You can think about it, how to solve it. We're not going to solve it, we are just discussing it. You can think how to solve it. So over here, three statements are given, and we have to infer what does it mean. Three professors are seated in a restaurant. The hostess asks them, "Does anyone want coffee?" So everyone want coffee. So over here, the critical word is everyone. The first professor says, "I don't know." The second also says, "I don't know." The third professor is saying, "No, not everyone wants coffee." From these three statements, the hostess, who is a very good student in discrete mathematics, so she understood what does it mean. So she goes and bring coffee for the professor who wants coffee. So as I mentioned, we need to prove our claim, whatever claims we make. Pythagoras once made a claim, so he had to prove his claim. We know Pythagoras theorem, so a squared plus b squared is equal to c squared. Base squared plus height squared is equal to hypotenuse squared. And then you can find a number of proofs for this thing. Very beautiful proofs. Another claim, for example, is here, n squared plus n plus 41 always give a prime number. Finding prime number is always a challenge. Prime numbers, if you recall, are those numbers which cannot be factorized. So finding prime number, we need very big prime numbers in our practical problems like cryptography, for example. So if someone claim, "I found a formula to find prime numbers, and that is n squared plus n plus 41. Should we believe? We will ask for the proof. So you can see, can you show that this problem is true or this problem is wrong? Proving wrong is also important, and this is called disproving. If you look it at carefully, or you can write down a program, you can see like when n is equal to 41, then this statement is not going to hold, because then this is going to be a composite number. It's no more prime. So these are some of the problems that we discuss in discrete mathematics. So in general, when we are discussing discrete mathematics, so we discuss two kind of problems. One is counting problem, and the others are logical statements, logical inferences, logical proofs. Hope you will learn. Good, happy learning. Thank you.